Good morning, everybody. So today we're mixing it up again. No camera, my camera working. So let me recap now. In the last class we had, I showed everybody how to solve equations, and we follow the steps. Rearrange. We basically isolate the variable, and we rearrange. And the last step was to divide by the coefficient of the variable on both sides. But if you go back, right, go back and look at that video. The last thing we did in that video, all of the variables were on numerator. So if I recap, so we're just doing a little recall. If I'm solving for x in 2x plus 6 is equal to 4 minus 3x, I move the x across, 2x plus 3x. I move the 6 across, 4 minus 6. I get 5x is equal to, what is that, minus 2. I'll divide by 5 on both sides. 5x over 5 is minus 2 over 5. U goes with U. And I get x is minus 2 over 5. All of the examples we did in the last class resembled something like this, where the variable or the unknown that we are solving for was on the numerator. But what happens if the variable on the denominator is on the denominator? Well, we have to figure out what to do. If the variable is on the denominator, I have to perform a couple steps. So before we perform those steps, I want to teach you all one thing that we have to know, and that is the property of cross multiplication. So what is this? I'm sure everybody encountered this already. Cross multiplication. Now I'll give you all what the conditions for this. We can cross multiply if we have one fraction on each side of the equal sign. For example, if I have 2 over x is equal to 4 over 11. I have one fraction here and I have one fraction here. To cross multiply, I will multiply the denominator by the opposite numerator. So this becomes 2 by 11 is equal to 4 by x. Now when I cross multiply, I do a very nice thing. I eliminate all denominators. So if you realize in this particular question, the denominator was a variable, and by performing this cross multiplication, I ended up putting the variable on the numerator. And we'll just repeat the steps from last week's class, where we rearrange and we solve. So let's actually perform an example here where we have to solve for x. Solve for x. Let me say I have 4 over 3 is equal to 2 over x. First thing I notice, brother man, the variable on the denominator. I don't want the variable on the denominator. I want the variable on the numerator, because I already know how to solve an equation where the variable is on the numerator. So what I go do? I go cross multiply. Now, if you do this little 2 arrows here is your indication that you're telling whoever marking your paper, here is the scene. I cross multiplying. 4 will multiply by x to give me 4x. And 2 will multiply by 3 to give me 6. I end up here, and this was I think step 3, where I just have to divide by 4 on both sides. 4x over 4 is 6 over 4. And I get x is equal to, I can reduce this as 3 over 2. Now, that's all well and fine, because it was easy for me to perform a cross multiplication over here. But from the time I have something like this, a half plus 3 over x is equal to 2/3, I end up in some problems. So ask yourself, pause the video and ask yourself, am I allowed to cross multiply? If you pause the video, I'll give you the answer now. I am not allowed to cross multiply because I have two fractions on the left hand side of the equal sign. So we are not allowed to cross multiply. So I want to figure out a way in which I can have one fraction on each side of the equal sign. Now I'll go back to our previous class on fractions. And I want you all to notice something here. When we add or subtracted fractions, I want you all to observe this here. I added two fractions and I got one fraction. I added two fractions and I ended up with one fraction. Down here, I added three fractions and I ended up with one fraction. Even when we started with algebraic fractions, I added three fractions and I ended up with one fraction. So I can see that LCM is a method in which I can represent or I can simplify the addition or subtraction of any number of fractions and bring it as 1. So if I perform a LCM here, I will be able to get one fraction on the left hand side. So let's do that. I'll go with big denominator, which is 2 and x. And if you all want to go through the long way and divide big denominator by small denominator multiplied by the numerator, you can go ahead and do so. I'm just going to give you all the solutions here. This will be 1 by x plus 2 by 3 is equal to 2 over 3. So now I have x plus 6 over 2x is equal to 2 over 3. So again, ask yourself, pause the video and ask yourself, am I allowed to cross multiply? And the answer is yes. Although I have more than one term on top, this whole thing here is a fraction. Well, I can cross multiply. You go by you and you go by you. Now my denominator 3 will multiply by my entire numerator x plus 6. So this will be 3 into x plus 6 is equal to 2 into 2x. I'm going to expand my brackets. I must multiply by everything inside. So this becomes 3x plus 18 is equal to 4x. Carry the 4, carry the 18. 3x minus 4x is minus 18. Minus 1x is minus 18. I'll divide by minus 1. Minus 1x over minus 1 is minus 18 over minus 1. You cancel with you. And I get x is equal to 18. Let me do our next example. Let me say I have another example where the variable again is on the denominator. 6 over 11 minus 4 over x is equal to 1 over 3. So I'll do the same thing again. I will calculate my LCM on the left hand side and I will express these two fractions as one fraction. So my LCM will be 11x. So again, if you want to go through the long way, by all means, go ahead and go through the long way. This becomes 6x minus 44 is equal to 1 over 3. I am allowed to cross multiply here because I have one fraction on this side and one fraction on this side. So do the cross multiplication for yourself, so by so. I'll have 3 into 6x minus 44 is 1 multiplied by 11x. Multiply the outside term by everything inside. I get 18x, take away 44 by 3. Let me just get my calculator and work that out. 44 multiplied by 3 is 132. Is equal to 11x. Rearrange 18x minus 11x is 132. 18 minus 11 is 7x is 132. I'll divide by 7. I'll get 7x over 7 is equal to 132 over 7. 7 goes here, and let's check and see if we can get a whole number for 132 divided by 7. We can't. So I will leave this as 132 over 7. If you want to leave it as a mixed number, by all means you can go ahead and leave it as a mixed number. So I'll put an example here for you all to try on your own. Let me say I have a third plus 3/4 is equal to 2/5 minus 7 over 2x. Now in this case, I'll give you a little tip. I have two fractions on this side and I have two fractions on this side. For now, calculate your LCM on this side, calculate your LCM on this side, perform your cross multiplication, rearrange and solve. So that's your tip I'm giving you all for this particular question. Now, we have different types of equations that we will encounter. Today is not going to be a long video by any means. We have different types of equations in which we need to solve. So let me try and separate the types of variables. One, we need to solve equations where the powers of the variables are 1. Of the variables are 1. And that is what we did last week, and to a certain extent it's something that we did this week. The second is when the powers of the variables are 2. And for now, this is all that we need to know, right? This is all that we need to know. In this particular example here, the power of the variable was 1, but the variable was on the denominator. In last week's class, the powers of the variables were 1 and the variables were on the numerator. Alright? So we'll just need to keep learning different ways in which you can solve for these variables. Now sometimes a variable could be hidden, right? Because let me just say, right? I mean, this one here is pretty straightforward. X squared plus 2x plus 1. X squared plus 2x plus 1. It is clear that, well, I shouldn't say the power. I should say the highest power. Alright, so let me rephrase this a little bit here. Instead of power, I'll say the highest power. And I'll rephrase this one as well. This is a little sneak peek for next week's class. Next week's class is going to be live, most likely. The highest power of the variables are 2. The highest power of the variable is 2. This fella is called a quadratic, and he will require a particular method to solve him. Alright? Now, it might look like, if I have this, x into x plus 4, the highest power of the variable is 1. Or is it? If I perform a little bit of expansion, this is actually x squared plus 4x, and the highest power of the variable is 2. So this equation will fall underneath a quadratic. Whereas something like this, x plus 4, this will fall under number 1, which is linear. Alright? So what I would like you all to do, actually do over these examples here on your own. Keep trying them. Do this one on your own a couple times and get good at it. In next week's class, we'll do a couple more, and then we'll dive into probably this or we'll dive into coordinate geometry. Feel free to comment on what topic you all want me to do next. I really want to do coordinate geometry next because it's very, very important to build that foundation. But if you all have any suggestions or any requests, please feel free to leave a comment telling me what you all want to do. Make sure subscribe, leave a like, and I'll see everybody in the next class.